Let's begin with meditation, the practice of the open way. Just lift your tongue up a couple of centimeters and feel the chi in your tongue. And allow your breath to go slow and deep. And imagine your tongue as the handle of the pump. And the breath is the pipe going down into the well of chi, of life energy, the core of your being, below the breath. Use the breath as a pump to lift the waters of life, chi, out of the well and into your being, to fill you with chi, fill you with power, fill you with life presence, fulfillment, enjoyment. This is the bliss of the breath. So stay in this power as I take you further into your understanding of the physics of the quantum vortex. A great mistake, a massive mistake, occurred in the foundation of quantum theory early in the 20th century. And that mistake was to assume that energy only occurs in the form of waves. And it's caused quantum theory to become incomprehensible. As Richard Feynman, the Nobel laureate, said, we don't understand quantum mechanics, we just get used to it. And this is a tragedy. It's a tragedy when we don't understand fundamental physics. In the 19th century, it was taught in physics, even at Cambridge, even until 1910 this was taught, that matter is based on vortex motion and light is based on wave motion. And that fundamental motion is energy. And Einstein established in 1905 that there's an equivalence between mass and energy, E equals mc squared. He showed that energy forms mass. Everything is formed of energy. But he didn't explain or describe exactly how energy forms mass. But when I was reading yogic philosophy at the age of 16, I read that the yogis had taught that the smallest particles of matter are vortices of prana, vortices of energy. So they anticipated Einstein not only by describing mass as a form of energy, but describing what that form is. It's the vortex. So what I did in my teens, and early 20s, the 1960s and 70s, was to develop a quantum theory, a new form of quantum mechanics based on the vortex, based upon an interaction between the vortex and the wave. And I found this is incredibly simple. This is my book, The Quantum Vortex. And look how little it is. And this is the whole of the physics that's in here, from the smallest quantum to the mightiest galaxy. The whole universe is explained in these few pages. That is the simplicity that comes into physics once we reintroduce the vortex idea. The problem is that in the Institute of Physics at Copenhagen, where they developed quantum mechanics, they dismissed all the 19th century models as naive realism. And that's a tragedy, because that put a block on anyone applying the vortex theory to quantum mechanics. But I've just overcome that block. You're going to see in a subsequent podcast how I dismiss the uncertainty principle, which is the foundation of quantum mechanics. I can disprove it. Therefore, I can dismiss naive realism. I can show there's a fundamental mistake in quantum theory. They're wrong to dismiss those models of the 19th century. They're valuable models. You see, in the 19th century, they didn't know that the atom was going to be split. They thought the atom was the smallest particle of matter. And when you apply the vortex theory to the smallest particles of matter, which are the subatomic particles, the whole thing becomes unbelievably simple, easy to understand, which suggests it's true. So, what's happening here is that the energy which we represent as a line of movement, as a string of movement, spins and forms a perfect sphere, the corpuscular subatomic particle. The inertia of this mass is set up by the spin. So Richard Feynman said the laws of inertia have no known origin. Well, actually, I'm explaining to you the origin of inertia, which is motion, which is spin. That sets up the static inertia of mass. The other form of energy, the wave form, sets up a different form of inertia, which is the inertia of wave motion. It keeps moving in a wavy line. It can't stop, because that's what it is, a bundle of wave motion. You see, there's nothing there in energy. There is no thing moving. Energy is more like a thought than a thing. So these are imagined states of reality. The Aboriginals were right. We're in a dream state. This is what Sir James Jeans said in The Mysterious Universe, one of the great British quantum theorists of the mid-20th century. In the 1930s, he published this book in which he said, the universe is more like a thought than a thing. So the vortex is the way energy is imagined to be to form matter. The wave form, the quantum wave, is the way energy is imagined to be to form light. And these two forms interact, and that sets up the physics of the quantum vortex, the quantum mechanics, the mechanics of the quantum vortex. A new form of quantum mechanics. It's not based on uncertainty. So what we are seeing here in the vortex is the dense center setting up subatomic particles. But as the vortex extends into infinity, it sets up space. Einstein said this when he was asked to put his theory of relativity in a single sentence. He said, move matter and you also move space and time. Because they're connected, they're the same thing. So space is sparse matter and matter is dense space. And they're both three-dimensional extensions because they're formed out of the three-dimensional form of energy, which is the vortex. It's a three-dimensional spiral. So mass is an illusion set up by spin. And what happens is that as the wave train drives into the massive particle, it enters increasingly spiral space. Now, when a car comes to a roundabout, space is a road, the car's on the road. You can't have movement without space, so the road is the equivalent of space. the car is the equivalent of a quantum of motion. And when the car comes to a roundabout, it goes round because the space goes round. The road goes round. So when the quantum enters the vortex, it's a spiral space path, which gets increasingly tight. And so the quantum drives into the spiral space path and gets caught. It's captured. I call this capture theory. But what happens here is that the inertia of the electron, which is a light vortex, is low because it's not very massive. It's a bit like trying to hammer a nail into a washing line, into a sheet on a washing line. The sheet keeps moving forward with the hammer blows of the nail. It's very difficult to get the nail into the sheet. And so it is with the vortex, electron vortex. As the quantum is driving into it, it's pushing it forward. And it pushes the electron forward in wave motion. And that is your wave-particle duality. That is why electrons move as waves, because they're pushed forward by wavy tails. So this is a picture in my book of the situation where you can see the wavy string of energy driving into the spiral string, setting up a marriage between the wave and the vortex. This is like the sperm entering the ovum, as above, so below. You could think of this as quantum sex or subatomic sex. And now the tail of the quantum sticking out of the electron drives the electron forward in wave motion, and the model for that is the tadpole. The tadpole moves in wavy lines because it's driven forward by the wavy tail. So what's happening in the quantum is very similar to what's happening in the world we live in. As in the microcosm, so it is in the macrocosm. What happens as energy enters the atom, it enters the spiral space paths of the electrons in the atom. And the electrons are driven in what you call the ground state, which is the lowest energy state of an electron in its orbit in the atom. They call it the ground state. And it's moving forever in that ground state, round and round and round. You've got the attraction between the electron and the protons in the nucleus acting like a string holding the electron in its orbit, and the wavy tail quantum is driving it forward in wave motion. But the electron is still irresistibly attractive. So if you imagine the first ground state quantum as the husband, and this is the wife, she's still attractive to other quanta, to other men, if you like. And so as another quantum drives into her, that's like the lover. He drives into her and she becomes excited. And he lifts her up into the excited state. But the triangle between the lover, the husband, and the wife is unstable. And after a time, she drops back into the ground state again, the marriage state. And the lover leaves, the disillusioned lover leaves as a photon of light. And that is happening here in this candle flame. What's happening here is that the combustion of the wax is generating energy. And this energy, this heat, is exciting electrons in the carbon atoms of the soot, the smoke that's coming up from the burn, and they're leaping from the ground state to the excited state, and then falling back from the excited state to the ground state. And as they do so, they emit a photon of yellow light, which is the frequency of yellow light has the frequency difference between the ground state and the excited state in carbon atoms. So these electrons are vibrating up and down as they absorb energy, release the energy, drop back, absorb more energy, releasing. So she's moving in and out of the marital and the triangle state, bang, back and forth, back and forth, back and forth, emitting light. But what's happening here, there's a little bit more going on. In the combustion, you've got carbon atoms from the wax combining with oxygen atoms from the air and forming carbon dioxide. And in the carbon dioxide, what's happening is as the carbon dioxide forms, electrons from in the excited state of the oxygen and carbon actually leave the atom that they were in, like the oxygen atom, and go into the carbon. From the carbon, they go into the oxygen. And they move around in an orbit between the carbon and the oxygen. So they spend some time in the carbon, some time in the oxygen. And that binds them together. It's called covalent bonding in chemistry. And so we see this in our own society, where sometimes the wife, instead of dropping back into the marital state, she goes off with her lover into another house. So she leaves the old atom and goes off into the new atom, but she doesn't stay there permanently. She comes back into the old home because she's got children there, she's got, commitments there. So she's moving back and forth between the new home and the old home. That is covalent bonding. Sometimes in chemistry, you get a situation where the wife goes off with the lover, the quantum lover, and never returns to the old home again. So this happens with sodium, the metal sodium. If you put it with chlorine gas, they explode. It's a very, very energetic reaction. And the electrons leave the sodium metal, the sodium atoms, and go off into the chlorine atoms. And the sodium atoms that lose an electron become positively charged because they've got more positive charges than negative. And the chlorine becomes negatively charged because it's now gained a negative electron. It's more negatively charged than it is positive. And that is sodium chloride. And they're bound together by the electric charge attraction of positive to negative. And it's rather like the home where the wife has gone off permanently and never returns. There's a lot of charge between the houses. There's a lot of acrimony, if you see what I mean. And so we can see the patterns in the quantum world are very, very similar to the patterns we see in our own world. And it's interesting that even the languaging is the same, that, when the man becomes married, when it's like the male energy channeled by the female, okay? So this quantum of energy is channeled by the vortex energy into useful work. It's like as soon as the marriage is over and celebrations are finished, it's out to work, you lazy hellion. You see what I mean? He's got to go out and do a job of work. And it's called that kinetics, which is the interaction between waves and vortices, between heat and matter, for example, sets up work. This is how you make engines work. This is how your car works. The pistons are driven up and down by the explosions of set up by these quantum reactions. So you can begin to see that the vortex helps us to understand fundamental physics. It makes it much easier, much understandable. We can begin to understand the quantum leap, wave-particle duality. We can understand chemistry, covalent bonding and ionic bonding. We get to understand the flame. I mean, even the languaging, you know, the old flame. I mean, here it is, the old flame. And we understand the flame in terms of the vortices, you know, the wave trains becoming attracted by the vortex, in this, from the heat, from the combustion. All these quanta are driving into the vortices of the electrons and the carbon atoms and exciting them, lifting them to the excited state, dropping back to the ground state, releasing the quanta as yellow light, photon emissions they call it. So I hope you've enjoyed this little physics lesson, and next time I'm going to talk to you about the quantum interactions, the quantum mechanics between bundles of energy and the massive particles, the protons. So thank you for being with me, and don't forget the open way. Namaste.